You were asking me that how will
Mm.
it comes to know that about the impure substances. So remember that there will be no sharp value. Okay, there will be a range. Okay, this is a sharp value 90.5. It means it is a fixed value. Okay, this is a fixed value.
Yeah.
But if at some place they have mentioned 90.5 degrees Celsius to 96.8 degrees Celsius, there is a range. This means this is impure substance. Okay,
Mhm.
so by this you can easily identify, and as well as you will see in the graph like this, the graph will not be uniform. Okay, for impure substance. Clear?
Yeah.
Okay. Compound X is a hydrocarbon. It contains 85.7 carbon, the mass of 1 mole.
I also didn't understand like the moles
Mm,
and stuff.
yeah, you can skip this.
We didn't do moles, I think. Yeah.
Yeah, we will do that in the in the next chapter, inshallah. That is about stoichiometry.
Stoichio, yeah, stoichio.
Yeah,
Yeah, that
mm,
chapter is a bit difficult.
it is bit difficult. It is very difficult. We will do that,
Yes.
inshallah. And in that there are so many numericals, there are so many formulas. But inshallah, we
Yeah.
will practice it. It will be, inshallah, by practice, you will be familiar with the type of questions. I can't
Mhm.
say that I will make it easy, but I can say that with practice, you can say your phobia will be less. Okay, you will be
Yes.
less scared of the questions.
Hmm.
That is the scariest part of the
Yeah.
uh, IGCSE. Yeah, the diagram shows a heating curve for a sample of compound X. Okay, this is X a solid, a liquid, or a gas at temperature 20 degrees Celsius? Okay, at
Hmm.
I think this one, yeah, at 20 degree. Now, what will it be? A liquid, a gas, or a solid?
It will still be like a liquid,
It will still be.
a liquid,
Why?
because A to B is like this, it goes from A to B as a solid, and then B to C it melts, and when it melts from a solid to liquid, it will go like it stays constant, so it will melt. Solid will become a liquid, and from C to D it will be still a liquid that's like heating up. So
Yes,
20 degrees will be a liquid.
yes, exactly. Write an equation for the equilibrium which exists in region BC. Write an equation for the equilibrium. Okay, it means what we will write. We will did mention the compound name. Okay, they didn't mention the compound name. We will write X solid, double arrow, like half arrow this, half arrow in this
Yes,
direction,
and
and
then
X
X alpha.
liquid. Yes, liquid. Yeah.
Yes.
You know what does this sign tells us?
Like it's equilibrium, like
Yeah, it
both
is
of the sides.
equilibrium. Yeah. It means
Yeah.
from here, from solid to liquid you can go, or from liquid you can come back to
Two
solid.
solid.
Yeah.
Yes.
Name the change of state which occur in the region DE. Yeah, what is this? DE.
Um, DE is the boiling point.
Yeah, this is the boiling point.
Yeah.
Explain how the curve show that a pure sample of a compound X was used. Yes. How by
Um,
this we can say this is a graph of a pure substance.
because you see at the melting and like the boiling points, like there isn't like various different temperatures. There's only a one fixed temperature.
Yes. And you know there is uniformity over here.
What do you mean by uniformity?
Uniformity means the lines are not like this. Like
Oh yeah,
like this,
like
like
it's not
yeah.
curved. Yes.
Yeah,
Yeah.
these are this you can simply say this is what we
Hmm.
can say this is constant. It has constant melting point and
Hmm.
constant boiling point, right? As well
Hmm.
as these are what else we can say? We can say flat plateau,
Hmm.
right?
Yeah.
So these are flat. These are flat. Okay. If you will see any impure substance, so what you will comment? You will comment that there are ranges of temperature. Okay. ranges
Mhm.
of temperature in melting and boiling point,
Yeah.
as well as the plateau will be not flat. What can we say about that plateau? These are the plateaus. This one we will say that these are irregular, or you can say curved or slanted
Slanted.
plateau. Okay,
Yeah. Mm.
so this is what you will write for. You can take the screenshot. This will you write for impure substances. Okay,
Mhm.
these lines would be slanted or curved, and there will be ranges of temperature.
Yeah.
Okay. Okay, yeah, next question. There are many questions of the there are many graphical questions, right? Ethanoic acid is
Yes.
colorless liquid at room temperature. It has a typical acid property. Okay, a pure substance of ethanoic acid is slowly heated 0 to 150, and its temperature is measured every minute. The result is represented. What name the change that occur in D to E? Yeah, what is the change in D to E?
D2E, it's the boiling point.
Yeah, it is the boiling point. What would be the
Mm.
difference in the region B to C if an impure substance has been there? Yeah. What will happen in B to C?
Like the graph would be changed. It will
Yeah,
be
there will
like
be
the temp,
curved.
like you told
Yeah.
me.
Hmm.
Yeah.
Curved
And
plateau. Hmm.
yes.
And
Like if there's a temperature, it will be like a different temperature
yeah, range
from
of
a different
temperature.
temperature.
Hmm.
Yes.
Sketch on the graph how the line would continue if the acid was heated to a higher temperature. Okay, if it is at higher temperature, the graph will be like this. It will be on this side
Yes.
towards temperature. Okay, on this side. If you increase
Yeah.
the temperature. Okay. Complete the following table that compares the separation and movement of molecules in region C to D and those in E to F. Separation between the particles from at point C to D. Yeah, what will be the separation of particles from C to D?
Uh, like it will it will have less kinetic energy.
No, no, no. You see the particles over here. What will be the particles now? Now it is melting, right? So the particle,
Yes.
it is the liquid state, right?
Yes.
Now can you tell me in liquid how the particles are arranged?
Like liquid, it's like irregular,
Yeah, there is the particles are quite
irregular,
spaced
and like
apart from
it's
each
a
other. Yeah, but
yeah,
not far apart. You can say they have some
and it's a
spaces.
different motion.
Yeah, and their motion is random. So it means
Yes.
you will mention that the particles have some spaces available. Okay, some free spaces are there.
hmm
But from E to F, if you see E to F, what is this? Now you see
E to
D to
F,
E. What
it's
will D to E? It will be what? It is boiling,
boiled.
right? Boiling point. So
Yes.
it means now this is gas, right?
Yes.
So there are you will say less free spaces C to D and there are more free spaces, right?
hmm
The
Yeah.
particles will be far apart. Movement in C to D we have figured out that this is liquid and this is gas. So it will be random and slow, but in the gas, it is random and fast, right?
Yes.
Can particle move apart to fill any volume? Yeah, about the liquid and gas. This we have done tomorrow. A similar question we have done. They are
Can
saying
particles fit?
hmm,
Uh, yes, it can.
in which gas or liquid?
Liquid.
No, you see, if you add liquid, whatever the liquid is,
No,
it
no,
will be
gas,
hmm,
gas.
the
Yeah,
gases
because
can
it's
fill.
like
Yeah,
yeah.
the gases. There is a question that was like yeah, this one. You see,
Yeah,
over here, liquid is just in the bottom, but gas can fill up the container, full container. Why and how?
because it has like a different like arrangement, and like it's a random motion, so it
Yeah,
can
the
spread out
particles are
anywhere.
very far apart from each other, and they are
Yes.
moving at a very high speed. That's why they will fill the shape of the container. But when we talk about the liquids, liquids have a fixed volume. Their volume is fixed.
Mm-hmm.
Gases, they don't have a fixed volume. Okay, their volume is not fixed. That's why their particles randomly move and they fill up the space of the container. But when we talk about the
Yeah.
liquids, their volume is fixed. They will fill a fixed region of the container. Okay.
Yeah.
Okay. This one. No, this one. Yeah, this one. Okay. Next, complete the word equation. Okay, we can ignore this. You have not done this. Calcium and ethanoic acid. Write a symbol equation. Ethanoic acid. We can ignore this. Okay. Element X can undergo the following physical changes. Name each of the numbered physical change as shown. Yeah, what are these changes? What is one?
Just give me one more minute. I'll be
Okay,
back.
okay.